Welcome, Algebra 1. This is section 5-6, parallel and perpendicular lines. The essential question is, how can you determine whether lines are parallel, perpendicular, or neither? Let's begin. So what are parallel lines? Well, they're two lines that are in the same plane that never intersect. So two lines and they'll never cross. They keep just going on and on forever. They'll never intersect. That's the key part. So let's compare the equations of parallel lines. So I've got the equations for the first one, y equals x plus 5. The second one, y equals x minus 2. Well, what you'll notice about parallel lines is they'll have the same slope. In this case, m, the slope, actually equals 1 for both equations. What's going to be different in parallel lines is the y-intercept. For the first one, y-intercept b equals 5, and then the y-intercept for the second one equals negative 2. So to have parallel lines, they have to have the same slope, and they have to have a different y-intercept. Those are the two key parts to have parallel lines. Same slope, different y-intercept. That's it for that. So let's talk about perpendicular, but before we talk about that, I need to go over opposite reciprocal numbers. So two numbers are opposite reciprocal for each other if they have these two properties. The numbers are opposite, so one is positive and one is negative, and the two numbers are inverses of each other. So you inverse the fraction or you just flip it. So for example, in the first one, these are opposites because the first one's positive and the second one's negative. They're inverses because 3/4 flips to 4/3. So I'm just taking that 3/4, flipping it, and it turns into 4/3. So it's opposite and reciprocal. The next one is also opposite and reciprocal because negative and positive, and this is 4/7, then flip them, and you get 7/4. Last one, 3 and negative 1/3 are opposite reciprocals because 3 is the same thing as 3 over 1. And this is positive, and the negative 1/3 is negative, and you can flip the 3 over 1 to get 1 over 3. So these are all opposite reciprocals of each other. Now, perpendicular lines. So perpendicular lines are lines that intersect, and they form right angles. So where they intersect, they form right angles. I draw this little square shape right here. This indicates something is a right angle, which is 90 degrees. So if you have one of those, you know all of these are right angles. Just like this. So everything is a right angle. How can you tell from an equation if two lines are perpendicular angles? Well, there's two properties here. The slopes are, well, it's really just one. Slopes are opposite reciprocals. So I have the two equations right here. Y equals 2x plus 6 is this line going like that. And the one going down is y equals negative 1/2 x plus 5. So these slopes here, the first one, the slope is 2. And the second one, the slope is negative 1/2. Notice 2 and negative 1/2 are opposite reciprocals of each other because 2 is like 2 over 1, and you're flipping that to negative 1/2. The y-intercepts can be anything. They can be the same y-intercept, they can be different, it doesn't matter. So the only thing for perpendicular lines is you must have slopes that are opposite reciprocals. Alright, that's it for notes. Let's try some examples. Pause the video. Okay, a line passes through 12,5 and is parallel to the graph of y equals 2/3 x minus 1. What equation represents this line in slope-intercept form? Alright, a lot of things going on here. So a line has to pass through the point 12,5, and it has to be parallel. When it's parallel, it has to have the same slope. So it has to have the same slope with this one, so that means if it's parallel, the slope m must be 2/3. So it must pass through this point, and it must have a slope of this. Well, we can write an equation in the point slope form. Y minus y1 equals m times x minus x1. In this case, my x1 is this, my y1 is that. So if I plug them in, I get y minus 5 equals 2/3 times x minus 12. Now it wants it in slope-intercept form, which is going to be y equals mx plus b. Basic idea is that you don't have parentheses anymore, and the y is isolated by itself. So what I want to do first is I'm going to distribute. To make it in slope-intercept form, I'm going to distribute that 2/3 to the x and the negative 12. So what I get is 2/3 x minus 12 times 2/3. Well, 12 times 2/3, what does that come out to? Well, it's 12 over 1 times 2 over 3. When you multiply that, what you can do with fractions is you can multiply across, but I can reduce first. The 12 and 3 reduce to 1 and 4. So then I'm left with 4 times 2 is 8, over 1 times 1 is 1, or just 8. So what happens over here is it's 2/3 x minus 8 equals y minus 5. Now I got to isolate that y, so I'm going to add 5 to both sides. And what happens now is I get y equals 2/3 x minus 3. And there's my answer in slope-intercept form. Y equals 2/3 x minus 3. All right, next example. All right, are the graphs of 4y equals negative 5x plus 12 and y equals 4/5 x minus 8 parallel, perpendicular, or neither? Okay, and explain. Let's talk about parallel first. I got to check that. So parallel has to have the same slope. But here's the thing. This equation's first equation right here, I'm going to call this equation 1, equation 2. This is not in slope-intercept form. I need to convert that. So for equation 1, I'm going to write that again. 4y equals negative 5x. So let's get rid of that line. Negative 5x plus 12. Slope-intercept form, I got to divide by 4 on everything. So what I'm going to get is y equals negative 5/4 x plus 3. So that's the first equation now. And then the second equation is right up here. So are they parallel? They have to have the same slope. And I have 4/5 and negative 5/4, so no, it's not parallel. Is it perpendicular? Well, perpendicular, I have to have slopes that are opposite reciprocal. So our slopes are going to be 4/5 and negative 5/4. Are those opposite reciprocals? Yes, they are, because it's flipped and one's positive and one's negative. So is it perpendicular? Yes, perpendicular. Why is it perpendicular? Because opposite reciprocal slopes. And that's your answer. That's it.